All right, so I just have just one partial reaction up on the board, and there's lots of information up there that is not only just a review of what everything that you've learned so far this semester, but how we can use certain terminology in here to explain what is actually perhaps going on. Okay, but before we get to that, I understand some of you are going to be gone on Thursday. So I was just explaining to the students that we're here. Okay, we got 3 ways that we can deal with this. Those students that are here on Thursday in class, they can take part 2 at that time. Okay, those of you who are gone on Thursday, you can come in before class because I do believe you're not leaving till 9. Come in before school and get that out of the way on on the 31st of March, or if you're gone on Thursday, you can come in on April, what would that be, April 4? Yes. April 4th, you could come in and get that completed. But then keep in mind, there's also a track meet on Monday, April 4th. So it's just one of those, you have to come in and just get it completed so it can be documented. So that's something to think about between now and tomorrow, so you have an answer when we talk about this again in class. Okay, so everything that we've learned so far, what can you tell me about this? This was our previous chapter. What is the symbol for lithium? Okay, what is the formula for the carbonate ion? Okay. Now, do you want to finish this out, or do you want to work on this one next? Okay. Go by your negative ion. So who's got the negative charge here? Okay. And this has a charge of negative what? 2. Okay. This is an alkaline earth metal, or excuse me, alkali metal. So it's in column 1, so it's got a charge of +1. Those charges do not add up to 0, so what do you need to do?
2 lithiums.
Okay, so 2 divided by 1 gives you 2, least common multiple. 2 divided by 2 gives you 1. We've got 1 carbonate ion. Okay, we can proceed to this. What is the symbol for tin?
SM.
What's the symbol for the chloride ion? Okay, go by your negative charges. What does the chloride ion? What does the chloride ion have for a charge? -1. Okay, and tin can have various charges. It can be +2 or plus. Okay, so we don't have to guess which one it is. This is a Roman numeral for what? Okay. So then, and we haven't done this before, but what is the Roman numeral for 5? Okay, that's Roman numeral 5. Is there a Roman numeral for 6? Of course, you could do that. And then here's number 4. There's 3, and then 2, and then, of course, 1. So 1, 2, 3, 4, 5, and 6. Those Roman numerals are used to tell you what charge these elements actually have. What's the least common multiple between 1 and 4?
4.
Okay, so what is 4 divided by 1? 4. The answer you get tells you what to put down here, and then 4 divided by 4, and we've got 1. Okay, so looking at this, what type of reaction do you think this would be? It's a double replacement. Okay? All right. So since these two compounds are on the left-hand side, anything that's on the left-hand side of a reaction are called what?
Reactants.
Those are all called reactants. anything that you have on the right-hand side of the arrow is going to be what? The reactants react with one another. What? Something that is produced, so it is a what?
Product.
So it is a product, okay? Now, we've got these small numbers. What are they called?
Subscripts.
Those are called subscripts. These are oxidation numbers or charges for these elements. They're called what? Maybe not subscripts, but rather exponents, or starts with an S as well. Super something.
Superscripts.
Those are called superscripts, okay? Then of these three subscripts, are any of them going to the right side for sure?
The 3 on carbonate.
Okay, so this subscript is going to the right-hand side. That is correct. Why is that?
So it's part of the equation.
Yeah, this is part of the formula, part of the equation, part of the formula. This 2 was added, so it would add up to 0. This 4 was put down here, so it would add up to 0. This is just part of the formula. So we know that that 3 is going over there for sure. Okay, so what they do is they split apart between the positive and negative charges. Okay, and then there's various ways you can look at that. These as variables, those as names of people who switch dance partners, however it is that you think would be most beneficial for yourself. But to me, I've always looked at it as the positive ions will only bond to negative ions. So we won't have tin bonding with lithium because they're two positive charges. They have to switch, so it's a positive bonding with a negative. So you had said lithium, being a positive charge, is going to bond to what on this side? You said it earlier.
Chloride.
Yeah, the chloride. It has to be a positive and negative charge that attach to one another. They do not change. Do we need to balance that compound out now? No, because this is still a -1, this is still a +1, those add up to 0. Okay? So that's one replacement. What is the other replacement?
And carbonate 3.
Okay? Remember that 3 is part of the formula. The charges will not change. Okay? What is the least common multiple between 2 and 4? Between 2 and 4, it's 4. So we've got one carbonate ion right now, but the least common multiple, you correctly said, was 4. What is 4 divided by 2? So that means you need how many carbonate ions? You need 2 carbonate ions. How do you illustrate 2 carbonate ions? You put it in parentheses, because if you do that, you would say you got 32 oxygens. We don't want 32. We just want 6 of them in all reality, because once you do that, okay, now you've got 2 carbonate ions. Do we have to do anything to the tin?
No, because it's 1.
Nope, because 4 divided by 4 gives you 1. That is correct. Okay, now you've got this equation up here. What's the next thing you should probably do? Okay, so give me some elements then. And what else? Okay, lithium's left.
2.
Lithium's right. Carbonate's left.
3.
Carbonate's right. Tin's left. Tin's right. Chloride's left. And chloride's right. Okay? So, would appear that this looks to be a little tricky, don't it? Okay? Because as you're looking at this, you might say putting a 2 here will balance out your lithiums, but what's the problem with that?
Chlorides.
Yeah, you don't have enough chlorides. Okay? So this trial and error is going to tell you that this does not work. So maybe lithium isn't the element that you'd want to start with, but maybe what would be better then? Okay? You could start with your carbonate, or you could start with what? Chlorides. Okay? So, you tell me which one makes most sense to you, carbonate or the chloride ion? Okay? So, we've got 4 chlorides on the reactant side and only 1 chloride on the product side. Okay? So, how do you get this up to a 4? Okay? And that gets distributed through the entire compound. What does that do to your lithium? What does that do to your chlorides? Okay? Now, you've got 4 lithiums to the left and only 2 over here. How do we get lithiums up to a 4 now? Okay? So if we put a 2 here, that gets distributed through the entire compound. So what is 2 times 2? Okay? And what is 2 times 1? And then what does that do to your equation then? Everything's balanced now. Okay? So we can now call this a balanced chemical reaction because we had these subscripts used to balance out the compound along with these superscripts or these charges. Then what are these numbers called? These are your coefficients. We got what? 2, 1, 4, and 1. Those are your coefficients. Okay? All right. So one of the things that we see happen, and very much like your activity, if you were to put salt in water, what does the salt actually do? Do you see it? Does it disappear?
Not right away.
Not right away. If you stir it, it's going to disappear because it is soluble. So what that means then, if this is perhaps let me start over here. This is a salt, okay? So it's very, very soluble. What we see happening then is this becomes insoluble now. So according to your activity, what do we see happening? What was that precipitate? It's an insoluble product, right? So that means one element is more reactive than the other. So what we would see happening is that activity series just tells you, okay, we're forming a salt. This is more active than what tin is, just because it's lighter or something to that effect. That's how these reactions take place. If one element is more reactive than another, that's going to cause this chemical reaction to take place. So this is more active. So when that happens, the activity series would tell you that forms your precipitate. Okay? All right. Let me pause this for just a moment. I don't know how much time had lapsed between the batteries in this microphone expiring as opposed to what we see here. Again, these are gases in halogens, same concept. Since if they're by themselves, you have to put a little 2 behind them. Okay? So then when you take 2 substances and combine them, what does that mean? That is a what type of reaction? Said it earlier. Yep, that's a synthesis. Okay? And then the last thing you'd possibly want to do with this is what? Balance it. You got 2 oxygens to 1. So what do we put in front of here? And then in front of here. Okay, now you got it balanced. 2, 1, 2. Okay, so even though this is on the left-hand side, it's still going to be a reactant. Okay, this would be your product over here because it's on the right-hand side. If something speeds up a reaction, what might that be? Starts with a C. It's one of your vocab terms. That's a catalyst. A catalyst will speed up a reaction. What might slow it down? That starts with the letter I. That was one of your vocab terms too. In something. What? An inhibitor. That's right. An inhibitor would slow a reaction down. Okay. So this is perhaps where we left off with on Friday, and what this is called is dimensional analysis. So let's say, for instance, if we have, we'll say 2 days. If we have 2 days, how many minutes would that be? So we have 2 days. We want to know how many minutes that would be. So we have to be able to cancel out some of these terms with like what we're doing here. So in a day, how many hours are there? It's 24 hours. So for a day, you get 24 hours. Okay? Now once we get it in hours, are we getting closer to minutes? Yes. Yes, we are. Because what we see happening is this term cancels out this one. Okay? Now, if we want to try to convert hours to minutes, do we know how many hours or how many minutes are in an hour? There's 60 minutes in an hour. So if we want this hour to cancel out, just like we did with the days, in this step, would hours go on top or on the bottom? It would go on the bottom, okay? So for every hour, you could put 1 in front, like you could here as well. For 1 hour, how many minutes are there? So now we have it in the term that we're looking for with dimensional analysis. We're multiplying or doing conversions. These days cancel out, these hours cancel out, and then we're left with just minutes, and that's what we're looking for. So these are next to each other, so you multiply those. Okay? So 60 times 24 times 2, or 120 times 24. Okay? Gives you 2880. In 2 days, there is 2,880 minutes. So the concept for this is fairly similar. Notice that some of these are going to cancel each other out, just like what we did up here. And these coefficients, remember we talked about this desk here. Do you want to deal with inches in length for talking about this desk or feet? Okay, it's 96 inches long, but what's another way of saying 96 inches? How many feet? 8. There's 8 feet in 96 inches. So that's just a counting unit. These are counting units as well. That's what we call a molar mass. A mole and a mass. Okay? So with this, if we're in moles of Ki, these have canceled. How do you get this mole to cancel? Well, we got the mole, but we want moles of what? Ki, like you just correctly said. And then this would be moles of what we're looking for, which is PbI2. What do these moles of Ki do to one another? They cancel each other out. What do these moles of PbI2 do to each other? They cancel each other out as well. And then what does that leave you for a label? Grams of what? PbI2. Okay? The only thing you have to do is because of this number here, we got to put down there. Okay? So what this means is, since these numbers are next to each other, what do we do with 5.3 and 461? Okay? So 5.3 times 461. Okay? That gives you 2,443. So 2,443 by multiplying those two numbers. We've got 166 on the bottom and 2. What do we do with these two numbers? Because they're next to each other. You're going to multiply them as well. So 166 times 2 gives you 332. And it's still one on top of the other. And now we got this into more recognizable math. What do you do with those two numbers? You will divide them. So 2443 divided by 332, and that gives you about 7.36 grams. Okay? Now, we said on pencil and paper, that is saying what you should have came up with. Okay? So now we can erase all of this. This is what we should come up with, 7.36. Okay? And then what you actually came up with when you removed the water from your beaker, you weighed it, took all the precipitate out of there, that yellow substance, weighed it again, and that's what you actually produce. So ideally it should be beneath 7.36. Well, maybe we're going to say it's 4.12. That's what you actually came up with in the lab. This gives you what's called a percent yield, and this is something that you are responsible for doing on your own. For those of you who take general chemistry in 2 years, you should be able to do this after we talk about it in class. So there's a reason why we go through this material. Okay, we'll talk about that a little more tomorrow, so we can get caught up here, and then we'll review again and start thinking about what it is that you want to do for Thursday, for those of you who are gone. And if you are here, okay, it's going to be a small class. If you want to take it when you're here, that's fine. Get it out of the way. But for those of you who are gone for Precision Ag, you need to decide you're going to come in before school and take it part of first hour before you go, or you're going to wait till Monday or even Tuesday, because there's a track meet again on Monday. But you leave at 11:30, so I would be led to, that only gives you probably about 20 minutes to be in class, but maybe you can get it done in that amount of time. Okay, so that's all I have. We'll catch up to you next time.